Batos FM transmitter. Transmitter for FM band 88 to 108 megahertz. Complete, very new kit, which includes mic and also Zener diode to stabilize the voltage and some improvements for sensitivity and for a transmission distance that I have done. And you will see it on the diagram. It used to be like this, okay, which has got a preamplifier, it's got a tuned circuit, and then of course oscillator and a transmitting transistor with the antenna that you actually connect. Now we used to supply it like this, let me show you, okay, without the actual microphone, and then customer would have to find its own microphone and get it connected and things like that. If he could use a dynamic microphone, of course he would hold, which wasn't that sensitive. He would have to hold it close to his mouth, which is with any dynamic microphone, basically the way you use them. Or, I used to modify for specific customers with the electret condenser microphone, except you have to add extra sort of circuitry in order to be able to make it extremely sensitive. So if you put this little unit somewhere in the room and you operate it from 9 volt, what I have done with the new sort of, I have included a Zener diode, which brings it down from 9 volt, operating 9 volt, brings it down to about 6 volt, 6,2. And that keeps my oscillator 100% stable until the voltage drops below, say, 6 volt or so. This is a top view basically of the actual transmitter, and one can easily sort of follow. Is the part list and things like that. Of course, you have to have some kind of a knowledge, about the value of the resistors or multimeter or something like that. What is a base emitter, collector, and so on. But although it's marked over here, but you have to know still something. You must have a soldering iron and things like that. It is a solder kit, basically. Okay, now let me show you on a spectrum analyzer. I'm going to do that. Right now, I got it basically from 0 to about 200 megahertz. Okay, over here, spike that you see, that's about 105 megahertz plus minus. That's a radio station, some Islamic radio station here in Springs. What you call it, extremely strong signal because it's not so far away from here. So just ignore that particular sort of spike. Now let me connect up battery on the transmitter that doesn't have the built-in microphone, and then you will see the carrier somewhere. Okay, now it's connected. And let's see, sorry, let me just get my, okay. Now what I'm going to do is I'm going to take a plastic adjustment screwdriver and try to adjust the frequency, transmitting frequency, and with this string pot. So that you can do, of course, instead of using a spectrum analyzer, you're going to be using, okay, if you look at it, can you see that, okay, can you see, okay, I'm going to center it somewhere around 100 megahertz. Okay, you can see now I'm going below 100, somewhere 80, and then going up and goes to about 108 megahertz, somewhere around there. Actually goes beyond that, but nonetheless, it's intended for 88 to 108. Now I'm just going to put it on 100 and I'm going to zoom onto that signal so you can actually see it. Okay, now I'm going to do this. I'm going to increase the resolution. Okay, let me just, okay. Okay, let me just find it. Okay, you can see it over there. Okay, and this is basically what the carrier, FM carrier looks like. But now, right now, it's unmodulated. Watch when I take a screwdriver and I just touch the sort of input of the you will see modulation. But then I will go to the one with the microphone, and then you can see it in real time as I'm talking, how it actually gets displayed modulation on the actual spectrum. Okay, now I'm not touching. Now I'm touching. Okay, now I'm touching. You can see how, okay, keeps on jumping because I'm in proximity also to the antenna, interfering with the oscillator. Nonetheless, okay, let me go to the one with the microphone, and that's the one that we supply with all components. So customer doesn't have to hunt for mic and battle sort of getting the microphone and things like that. Okay, so right now it is connected. Let me just show you. All right. Now let me just go over here and just put it in somewhere. That's again on 101 megahertz. Now I'm using this one with the built-in mic. Now watch when I increase the resolution. 1, 2, 1, 2. Okay, watch now. 1, 2, 1, 2. You can actually see the amplitude more or less stays the same. The amplitude stays more or less the same, but the frequency gets shifted. 1, 2, 3, 4, 1, 2, 3, 4. Okay, testing and checking, testing and checking. Okay, and of course, if I want, I can again, with a screwdriver, plastic, so it does not affect it, the actual frequency, I can actually trim it and sort of align it to whatever frequency I want between 88 and 108. So, in a nutshell, that's basically Batos FM transmitter, but more sort of powerful, longer distance, and as I said, much bigger sensitivity with the circuitry that I have added to the circuit, and changes, and much more stable. So, it is a nice little project, and it can be built within, say, half an hour, call it an hour for a non-electronic guy. And the nicest thing about the kit is it works first time, every time. There is no sort of two things about it. On that note, I hope you enjoy my little FM transmitter. And of course, I've been transmitting right now, and as I was speaking, you can actually see the look at it there, 1, 2, 1, 2, just sort of closer to the spectrum analyzer. All right, thank you for watching Batos FM transmitter. Till the next time. Thank you.